Okay, so just a quick demo of where we are with the wind farm risk application. So this is a simple user interface that's designed to aggregate risk across an entire portfolio of wind turbine assets. So you can see this list right here. Each row in it represents a different turbine. You have a map that shows the placement across North America. You can drill into a specific turbine and see turbine-specific attributes down here, as well as risk profiles for the three most common failure modes. So I'm going to select this turbine, which actually represents the one that I have a physical model of. I'm going to go to view details here, and this is going to show me a real-time sensor measurement graph. You can see some various measurements up here, including rotations per minute, the amount of vibrations, air pressure, humidity, and even wind speed. And then what you're seeing in the time series down here are actual vibration readings from the turbine that we have a model of. So the blue bar obviously are the vibrations. They're fairly well randomized between, say, 2 and 5, which are just arbitrary numbers that we've used to represent units of vibration. Then the green line is a moving average over the last 20 minutes, and the orange line is a upper Bollinger Band, which represents 5 standard deviations added to the moving average. So if that blue line tips above the upper orange line, that means that there is an event that would not occur any more than 0.3% of the time, or whatever the standard deviation math is. I think that's right. So I'm going to go to the turbine model that's spinning right now, and I'm going to simulate a vibration. We're going to see what happens over here in the graph. So here's the spinning turbine. You can see that just the slow movement that you can observe right now is what's generating those very small vibrations. You can see it's hooked up with the Raspberry Pi. There's an accelerometer attached to the top. And then I've got this little vibration motor down at the base. And this is how I'm going to exert vibrations that exceed the standard deviation. So I'm just going to plug this terminal into the 9-volt battery and let it vibrate for more than 500 milliseconds. Oh, shit. Okay, so I just broke it. Okay, but I mean, if that actually happened, let's see what this would show up on the graph. Okay, so there's a major spike, I mean, beyond anything that we would ever expect in this vibration time series. You can see that spike's represented by the blue lines. The standard deviation just went up significantly because it completely threw off the variance average. And since the turbine literally just broke, what I can demonstrate is that there will be an incident report created for a service technician automatically, which is right here. And there's going to be a problem report that's created in Windchill, which is the engineering environment, that tells an engineer that this turbine may have the propensity to have these types of failures, so they may need to consider these types of risks in the next version of the product.